This lesson is about graphing linear equations in slope-intercept form. What we'll do is we're going to get the equation, the linear equation, into slope-intercept form, then use the y-intercept and the slope to graph. So our steps are going to be to solve for y, graph the y-intercept, and then use the slope to find more points. Well, first of all, slope-intercept form is y equals mx plus b, where m stands for the slope, which equals rise over run, and the b stands for the y-intercept. So that's the point of 0, b, where it crosses the y-axis. So this form is going to be critical for using these steps to do the graph. So let's look at this example here. This is y equals 3/5 x plus 2. So as we have with our steps here, we've got it in y equals form. We're going to start with the y-intercept first. The y-intercept is 2. Go to the y-axis for that. Don't make the common mistake of going to the x-axis. It's on the y-axis. Y-axis is the vertical axis here. Plot the point 2, so that's our starting point right here. And then from there, our slope is 3/5, so we go up 3 units, we rise 3, and we go over, run 5 units to come up with another point, and then draw our line. You can do more points from there as well. Let's do some examples. So starting with this example number 1, 2x plus 4y equals 12. Get y by itself first, so I'm going to subtract 2x from both sides. So I get 4y equal to negative 2x plus 12. Now we're going to divide both sides by 4. Every term gets divided by 4, so we just have a y here. Negative 2 divided by 4 is negative 2/4 x. And then we divide 12 by 4 and we get a 3. I'm going to just rewrite that in simplest form, negative 1/2 x plus 3 for our slope-intercept form. So on this one, we start our graph at 3 on the y-axis, so 1, 2, 3, starts me right there. And then my slope is negative 1/2, so I'm going to go down 1 unit when I go over a positive 2. Down 1 unit over positive 2. And then I draw my graph connecting those points, using the y-intercept and then slope to draw the graph. So there's my graph. Let's try this one. Again, getting the y by itself first. Here, the y is over here, so let's subtract 18 from both sides. So 3y will equal 9x minus 18. Now we're going to divide every term by 3. So you divide by 3 and you get y equals 9 divided by 3 is 3x. 18 divided by 3 is 6, so minus 6. Now, it's very common to write it with the y on the left-hand side. You don't have to because it's the same thing, but we use the symmetric property to just have them swap sides. So y equals 3x minus 6. Now, my y-intercept is negative 6, so I'm going to start down here at 1, 2, 3, 4, 5, 6 on the y-axis. Now my slope is a 3. Well, we want it to be a fraction for rise over run, so I'm going to treat that as a 3/1. So I'm going to go up 3 units, 1, 2, 3, and over 1 unit. Up 3 units and over 1. Now we draw our graph. There is the graph using slope-intercept form to draw the graph. Last example here. Let's get the y by itself. This one's a little different, so let's take a look at it. Subtract 16 from both sides to get the y by itself, so you get negative 16. Divide by 4, you get y equal to negative 4. Now there's no x term. So how do we write it out in slope-intercept form? Well, since there's no x term, that's 0 x's. So we could rewrite this as y equals 0x minus 4 if we want to list it in slope-intercept form. Y equals negative 4 is fine because all that means is all the points on it are going to have negative 4 as the y value, no matter what the x is. Think of it this way. If I draw that line at the y-intercept of negative 4 here, notice that that horizontal line has a slope of 0 because we're rising 0 as we run over. We don't go up, we just run. So rise nothing, run, run, run. We keep going to the side. So a horizontal line has a slope of 0. So we have our graph of y equals negative 4 as a horizontal line. So to graph equations in slope-intercept form, you follow these steps of solving for y, and then when you have y equals mx plus b, start with the y-intercept, that last number, the b, it's what goes on the y-axis for your graph, and then use your slope as rise over run to find more points and graph your line.